In this video I'll show how to use the graphics calculator and the Euler program to approximate the position of a y-coordinate given the varying steps. First up, the question taken from the textbook is found on page 284, example number 11. The differential equation is dy by dx equals ex plus 1. Our starting point is x equals 0 and y equals 1, and I'm going to estimate the value of y when x equals 0.5. So on the graphics calculator, we go to Program. I have a program in here called Euler. If I execute that program, and first of all it wants the differential equation, which was e to the power of x plus 1. And now it's after the starting points. So a is the x-coordinate, which was 0, and f of a, the y-coordinate, was 1. We want to work out the approximate value of y when x equals 0.5. So we enter 0.5, the b value here. And now the step size. In the example, we had a step size of 0.25. And 2 steps would take us up to a value of 0.5, which is the value we want to work out the y-coordinate for. The number of steps is 2. And there's the first y-coordinate, and here is the approximation of the y-coordinate when x equals 0.5. And here's the textbook solution once again, and we can see this was the first y-coordinate calculated for the first step, and our final y-coordinate of 2.071 matches the value from the calculator. This is the value when x equals 0.5. Now I'll complete the calculation using 5 steps. So we'll reduce h to 0.1 and compare our solution to that in the textbook once again. So back onto the calculator, I'm into the program, I've entered the differential equation, and the starting point remains 0, 1. And once again we're working out the y-coordinate when x equals 0.5. Now the step size is 0.1. and number of steps is 5. And now we get the calculations of y for those 5 steps, finishing up with 2.1168, which is a bit better than the 2.071 we got previously. So here's the textbook solution, and we can see down here we've got 2.1168, which compares to our value from the calculator of 2.116825.